SpaceX Falcon 9 launch. Sonic boom alert for Southern California and NASA's Tracers mission explained. Get ready, Southern California. A SpaceX launch scheduled for Tuesday morning might just shake things up a bit with a sonic boom that could be heard across the region, according to officials. The Falcon 9 launch of NASA's Tracers mission is set to take off from Vandenberg Space Force Base's Space Launch Complex 4 East at 11:13 a.m. Pacific Daylight Time, with a launch window of 57 minutes. But here's where it gets interesting. About 8 minutes after liftoff, the first stage of the Falcon 9 will land back at SpaceX's Landing Zone 4, also located at Vandenberg Space Force Base. And this is the part most people miss. This landing could create one or more sonic booms that might be heard by residents of Santa Barbara, San Luis Obispo, and Ventura counties. However, the exact experience will depend on weather and other conditions. If needed, a backup launch date is scheduled for Wednesday at the same time. So what's the big deal about Tracers? It stands for Tandem Reconnection and Cusp Electrodynamics Reconnaissance Satellites, a program that aims to help us understand magnetic reconnection and its effects in Earth's atmosphere. In other words, scientists will be evaluating how weather in space affects the weather on Earth. But here's where it gets controversial. In May, a sonic boom shook most of Southern California as SpaceX's Dragon spacecraft re-entered Earth's atmosphere after a launch nearly a day earlier. Some people loved the excitement, while others were not so thrilled about the unexpected noise. So what do you think? Are sonic booms a small price to pay for the advancement of space exploration, or should we be more mindful of the potential disruptions to daily life? SpaceX launches NASA's Tracers mission. Sonic boom expected. Prepare for an exhilarating event as SpaceX is set to propel NASA's exciting Tracers mission into the cosmos from Vandenberg Space Force Base this Tuesday. Residents in the surrounding areas might just experience the thrill of a sonic boom echoing throughout the region. The launch is scheduled to unfold within a 57-minute window that begins at 11:13 a.m. If you want to witness this momentous occasion, tune in to the live stream. https://www.spacex.com/launches/mission/question mark mission ID =Tracers, which kicks off about 15 minutes prior to the rocket's ascent into the sky. Mark your calendars because approximately 8 minutes after the launch, SpaceX will attempt to bring the first stage of the Falcon 9 rocket back to land at Vandenberg. The powerful rebound from this landing could result in one or more sonic booms heard in Santa Barbara, San Luis Obispo, and Ventura counties. Who wouldn't want to catch that adrenaline rush? The Falcon 9 will serve as the vessel carrying Tracers, short for Tandem Reconnection and Cusp Electrodynamics Reconnaissance Satellites, into low Earth orbit. These twin satellites are on a mission to delve into how solar winds interact with Earth's magnetic field. NASA emphasizes that the insights gained from Tracers will not only enhance our understanding of this explosive phenomenon known as magnetic reconnection, but also arm scientists with knowledge that could prepare us for significant impacts, like stunning auroras and potential disruptions in telecommunications. What's more, the duo of Tracers will embark on their journey alongside several other satellites, including SIP's Epic Athena, Skycraft 4, Maverick Space Systems Real, Tyvak Slide, and York Space Systems BARD. It's a collaborative effort that showcases how space exploration brings together various players. In case circumstances change and the launch does not go as scheduled, SpaceX is prepared with a backup opportunity available at the same time on Wednesday. Will you be following along with this remarkable mission? And remember, while some folks may argue about the importance of space exploration, there are others who believe the resources could be better spent tackling issues on Earth. What side of the debate do you find yourself on? Let's hear your thoughts. NASA launches 2 new satellites to forecast solar storms. Imagine a dazzling natural light show in the sky that not only inspires wonder, but also hides a potentially devastating threat to our modern technology. This is the enigma of solar storms. The mesmerizing northern lights, or auroras, have fascinated people for centuries. Yet, the same energetic particles from the sun responsible for these stunning displays can wreak havoc on Earth's electrical systems and disrupt communications worldwide. But here's where it gets controversial. While we rely heavily on technology vulnerable to solar activity, our understanding and preparedness for these natural events are still evolving, prompting NASA's latest mission to deepen insight. Earth's magnetosphere acts as a powerful magnetic shield, protecting us from the relentless flow of charged particles streaming from the sun, known as the solar wind. This invisible shield generally deflects these high-energy particles, safeguarding satellites, power grids, and communication networks. However, the defense isn't perfect. At the Earth's north and south poles, there exist weaker spots called polar cusps. Think of them as open gateways or funnels through which solar particles can funnel directly into our atmosphere. When particles from the sun enter this funnel, something fascinating yet complex happens. Earth's magnetic field can interact and realign with the sun's magnetic field in a process scientists call magnetic reconnection. This event unleashes enormous energy, sometimes equal to the electricity the entire United States consumes in one whole day. While this explosive energy can paint the sky with vivid auroras, it also has a darker side. Intense magnetic reconnection events can disable satellites, disrupt GPS signals, and even cause significant electrical blackouts. As the sun currently reaches the peak phase of its roughly 11-year solar activity cycle, these occurrences are becoming increasingly relevant. To unravel the mysteries of how magnetic reconnection unfolds and its subsequent impacts, NASA is launching two innovative research satellites. Set for Tuesday at 2:13 p.m. Eastern Time, these satellites will lift off aboard a SpaceX Falcon 9 rocket from Vandenberg Space Force Base in California as part of a rideshare mission. This tandem launch is designed to give scientists a frontline view of the Sun-Earth interaction right inside the polar cusp regions. Named tracers, tandem reconnection, and cusp electrodynamics reconnaissance satellites, the mission involves two spacecraft flying in tight formation in low Earth orbit, speeding at more than 16,000 miles per hour. One satellite will follow the other with a very brief delay, just 10 to 120 seconds apart, allowing researchers to observe space weather changes almost in real time. David Miles, a professor at the University of Iowa and the principal investigator of tracers, described this approach as groundbreaking. Having two spacecraft so closely spaced lets us distinguish whether particles are accelerating, slowing down, moving around, or turning on and off, he explained during a NASA press briefing. Each satellite is equipped with a comprehensive array of instruments designed to measure how the sun's superheated, ionized gas, known as plasma, affects Earth's magnetic environment. This data is crucial because it enables us to better predict solar weather events that could endanger critical technologies on the ground and in space. Joe Westlake, NASA's director of heliophysics, stressed the importance of the mission's findings. The knowledge we gain from tracers is vital for predicting how solar energy impacts Earth space weather, which can affect everything from GPS and satellite communications to power grids and even astronauts operating in space. This mission is a key step toward protecting our modern way of life and ensuring safer space exploration. Concerns about space weather have been mounting as solar storms have historically led to significant problems. Massive blackouts, loss of satellite functionality, and disrupted navigation systems being just a few examples. Surprisingly, many people don't yet fully grasp how deep the influence of solar weather runs, even affecting essential human activities and technologies daily. Understanding the sun and its space environment is more important than most realize, Westlake emphasized. Space weather touches every human being and nearly all systems involved in space and daily life. Tracers is part of NASA's Small Explorers program and is designed for at least a one-year mission duration. However, there is good reason to believe these satellites may continue to provide valuable data beyond their initial planned timeline, offering ongoing protection against surprises from our star. But here's a question for you. As our society becomes increasingly dependent on sensitive technology, should more resources be dedicated to studying and forecasting solar storms? Or is this attention disproportionate given other pressing issues? We invite you to share your thoughts. Do you think missions like tracers will be enough to shield us, or is it time to rethink how we prepare for space weather disasters?